Where can you find information on a running computer? Can you access the physical drive? Well, yes you can, but it's not that easy. Can you access the logical contents? Yes you can. But where else might you find information on a computer? How about in RAM? That's what we're going to do today. We're going to capture RAM and virtual memory and see if we can pull anything out of it. So what I've got is, if you've watched the video on FTK Imager, I have a Kingston thumb drive that has FTK Imager 3.1.1 installed. So what we're going to do is we're going to use this to capture RAM on this XP virtual machine. We have our USB thumb drive and we have our virtual machine, and we want to capture RAM and virtual memory. Well, as it turns out, on Windows XP and on up, the virtual memory is called pagefile.sys. And to access RAM, there are several ways to do that, but I find the easiest way is just to use FTK Imager and put it on a thumb drive or a CD-ROM drive. It's all self-contained, and you can capture RAM very easily that way. And so if you think about it, what's happening right now? Well, things are changing not only on the file system, but also in RAM. So if you think that there's something in RAM that's important that you need to get before it's flushed out, you need to grab it as quickly as possible. And so what we want to do is to install, or rather insert, our USB thumb drive. And since this is a virtual machine, we're going to need to indicate that this needs to be connected, which will take a moment. Now it's connected, and we need to go in and we need to start FTK Imager. And remember, we want to work as quickly as possible and make as few changes as possible, because any kind of changes that we're going to be making, and just the fact that the system is running, it's going to be changing the system and changing what is in RAM. And so we can click on File, go to Capture Memory. The destination path, do we want to save it to the hard drive of the VM or the physical machine? No. Let's get it off that and save it on our thumb drive. And so let's go here. We're going to make a new folder called Evidence. We click OK. And we also want to include, notice, the page file. So anything that's being swapped out to the page file we can capture as well. That's currently in the pagefile.sys. And so now it's dumping everything that's in RAM, and it will copy pagefile.sys second, and the process will take a couple of minutes. And this is a 512 megabyte system, so it's going to be a little slow, but also it doesn't have much RAM, so it will go fairly quickly. So I'm going to pause the video while this runs. Okay, just to let you know, after about a minute and a half, it's 61%. I'll pause the video again. Okay, another minute and a half, and we're up to 91%, so we're getting close here. And now Imager is extracting pagefile.sys. And as I speak right now, the page file is probably being changed. So it's going to get a moving state. There's going to be a moving state of the swap file. So it may or may not get the information we need, but we need to get it as quickly as possible before it's overwritten. So now the memory dump is complete. We have RAM and we have our swap file. We can close this. If we did this wrong, would it make sense to go back and do it again? Well, yeah, you could, but it's not going to be in the same state, either RAM or the swap file, that it was when we first plugged it in. So we need to make sure that we do that as quickly as possible. So now we can go ahead and we can just pause this. Let's go back up here and disconnect this and connect it back to the host. And let's see what we've got. And so here are the contents of our thumb drive, and we have our evidence file, and it looks like we've got a couple of files here. We have memdump.mem, which is our memory dump, which is about 512 megabytes, and our pagefile.sys, which is about 50 megs. So what are we going to do with this? Well, there's different things we can do with this. What are we looking for? Are we looking for text? Is it ASCII text? Is it Unicode text? Are we looking for JPEGs or Word documents? Or we could be looking for any type of file, even a binary file. You can have binary files in memory as well as in the swap file. In this instance, we need some kind of data carving tool, because these are really binary files. And so the best way to recover meaningful contents from these is to use some type of carving utility. So let's start out by looking at memory and how we might go about recovering, let's see, ASCII text. Recall we've used the strings command in Linux to recover text from binary files. And it just so happens there was a company called sysinternals that made a lot of great command line utilities back in 2000 and on, and it was bought up by Microsoft. And there's the guy Mark Russinovich, who wrote some good books on digital forensics and wrote these tools. And one of these is called Strings. And you can see where you can download all the sysinternal tools here on the Microsoft site. And so I suggest you download this, and you notice that there's a man page right here that indicates how to use this. So notice that you can do an ASCII only search, or you can do a Unicode only search, and the default is Unicode and ASCII. And so I suggest that when you download this, that you copy this to something in your path. And simply what I did is I copied this to something in my path, which is the System32 folder. So I just dumped the files in the System32 folder. Okay, so that will allow us to recover the ASCII and Unicode strings from both the files. What about other types of files? JPEGs, GIFs, PNG files, Word documents, binary files, and so on. Well, this is something that we used in our introduction to forensics, and that was something called Photorec. And that is a free program that does data carving based upon the signature, that is the header of the file. And you have versions available for Windows and DOS, and there's versions available for Linux as well as the Mac. But they all work the same, and they all work very well. And so you can go to this site right here. This is actually the step-by-step procedures on how to run Photorec. And there's a couple of ways to do it, but I'll show you how I did it. But you need to download this. And what I did was, to make it easy, let's see, I downloaded Photorec. You're going to need to extract it, and I would just leave everything in its location. That is, don't copy anything anywhere, because it needs this sigwin1.dll in order to run appropriately. And then I copied my memory dump to that folder, as well as the page file. And remember that I copied the strings to the System32 folder, so I can run that anytime. And I went on ahead and I looked at this to make sure it would run, and that's why I've got this set up the way it is. And so you can create the command prompt. You can go to the desktop, and what was this called? This is actually the file that you download. It includes test disk as well as Photorec. And here are the contents. So here's our memdump file and our pagesys file. Notice that here's Photorec right here. Now you can run Photorec on any type of media, including a DD or a hard drive or a DVD or a CD. What we've got here is we've just got a binary file. We've got 2 binary files. Does it work on those? Yes, it does. And I know that because I ran it. So let's do something. Let's run strings first. Let's run clear here. What is it? CLS? I'm not in Linux. So let's run strings, and I'm just going to run the default ASCII and Unicode version of strings, and I'm going to run it on memdump. And I want to output that to a file called memdump.strings. So what that's going to do is that's going to give me all the ASCII and Unicode characters, more than 4 or 5 continuous sequence of characters. We run this. I'm going to pause the video just for a second because it takes a minute or two. And that didn't take long at all. Whoops. So if we want to look at the contents of memdump.strings, you can see all the human readable strings are pulled out. Now we could go through here and look at all the strings, and we may or may not find what we want, but it's always good to have some notion of that for which you're looking. That is, you got to have some idea of what you're looking for. Otherwise, you're going to have to just go through here a page at a time by using the spacebar character. Type Q to quit. Okay, so that's strings. And for the second part, we can look for files that have headers. Okay, so now we can run Photorec. All I did was type photo and hit tab a couple of times until the autocompletion worked. And then let's run on memdump.mem. I did the same thing there. I typed mem and then hit tab for autocompletion. And wants to run an administrator. Yes. It's not a signed application. So there we see we have got the appropriate file selected, memdump, 512 megabytes. Notice that it says proceed. Do we want to proceed? Yes. Okay, notice at the bottom we have options and a file options. Let's arrow over to file options and hit enter. And we see all the different type of files that are supported in here. So this is a wonderful recovery tool. Look at all the different files that are supported. So I want to disable all the file families because I don't want to have all these. Let's look for, let's just look in this instance for the GIF. So I hit the space bar, and then let's look for JPEG, and then let's look for PNG files. And we're almost there. PNG. Here we go. Notice it says B to save the settings. So I'll type B. Settings recorded successfully. OK. And return to main menu. And arrow back over to search. Let's hit search. And to recover lost files, Photorec needs to know the file system type where the files were stored. This was on Windows, so it's going to be a FAT or NTFS. We hit other, and now it wants to know where to save the recovered files. Now remember, it's not looking at a master file table or a root directory, so it's not going to recover the file names or the extensions or the date and time, because that could be overwritten. All it's going to do is to look at the file headers and in file footers and carve everything out from there. So what it's going to do is to create random directories. Actually, they're not random, they're sequential. Notice that I've already run this once right here. Notice it had 5 directories. It's going to have dump so many files in each of these directories. And the files will be numbered, but it can have an extension. Why might these files have an extension? Because it knows the header and the footer. And if it has the appropriate header and the footer, it can tell you the extension. It just can't give you the file name. Okay, so where do we want to save these files? Notice the dot, the current directory. That's good. C when the destination is correct. So we're going to hit C over here. And that's it. 43 files. It went through everything and recovered 43 files. Recovery completed. Let's hit quit. And oops, quit. And quit and get out of there. Let's go back over here. And now this is from the previous recovery. And so what I did then was I ran everything just to see what it would do. But notice all the different files it got. Notice that the files are numbered according to the sector in which they were found. It's because notice these are sequential. Notice that some of these have an extension. In fact, it's yeah, okay. And going down and see some of the files that are recovered. There's just one of those right there. And so what we've shown here is that you're able to do a live response, and you're able to recover the contents of both the memory, RAM, and remember that's changing, so 10 seconds from now it's going to be different than it was 10 seconds ago, and it's going to be even more different a minute from now. And that you can grab pagefile.sys, and you can grab ASCII and Unicode characters, and we can also grab other types of files as long as they have a header and a footer, and it allows data carving tools to identify what to carve out and from what clusters and sectors.